Welcome to The Explainer. I am so thrilled to have you here today. If you've ever felt that sudden, slight knot in your stomach at the sight of a division problem when your phone or calculator is completely out of reach, well, you are in the perfect place. Today, we're going to completely demystify long division. We are going to take what looks like a complex math hurdle and transform it into a surprisingly simple, predictable, and, dare I say, deeply satisfying loop.
I mean, we've all been there, right? You're trying to split a complicated bill, you're calculating materials for a DIY project, or maybe you're just helping someone out with their math homework, and suddenly you realize you are completely stuck without a calculator. It is incredibly empowering to know that you've got the mental tools to solve these problems by hand, anytime, anywhere. And that is the real-world utility of what we're mastering today.
Okay, let's dive right into this. Here is our roadmap for today. We're going to conquer this in 5 stages. First, the division house setup. Second, the 4-step loop. Third, dealing with remainders. Fourth, dividing larger numbers. And finally, the decimal point trick. All right, section 1, the division house setup. Before we crunch any numbers or do literally any math at all, we have to know exactly where our numbers live. Getting this foundation right makes the whole process pretty much effortless. In long division, we use what's often called a division bracket, but honestly, it's easier to just think of it as a house. We only have 3 key vocabulary words to remember here. First up is the dividend. This is the number actually being divided, and it goes securely inside the house. Next is the divisor. That's the number you're dividing by, and it stands right outside the front door. And finally, the quotient. This is our ultimate goal, the main answer, and it gets to sit proudly right up on top of the roof. Let's look at how this maps out with a really simple example. 8 divided by 3. You can see the standard linear equation at the top and how perfectly that translates into our division house right below it. The 3 is our divisor, waiting outside. The 8 is our dividend, resting inside. And that empty space above the line, that is VIP parking reserved for our quotient. Keeping this mental picture in your head is going to make everything else an absolute breeze. Moving on to section 2, the 4-step loop. Now that our house is built, we are ready for the core engine of this entire explainer. The crucial point here is mastering this unbreakable 4-step sequence. Divide, multiply, subtract, and bring down, or finish. Let's do a quick mental test run with 9 divided by 4. Step 1, divide. How many whole times does 4 fit into 9? Exactly 2 times. Step 2, multiply. 2 times 4 is 8. Step 3, subtract. 9 minus 8 is 1. And step 4, we look for numbers to bring down. There aren't any, so we finish. Once you lock in this rhythm, divide, multiply, subtract, bring down, you can literally solve any division problem on Earth. All right, section 3, dealing with remainders. Because, let's be real, numbers rarely fit together perfectly neat and tidy. Let's look at exactly what happens when they don't, using our earlier setup of 8 divided by 3. We kick off step 1, divide. We're asking, how many whole times can 3 squeeze into 8 without going over? If we run through the multiples of 3 in our head, well, 3 times 2 is 6, and 3 times 3 is 9. 9 is obviously too big, so the largest multiple that safely fits is 6. That means 3 goes into 8 exactly 2 times. To finish that divide step, we just pop that 2 right up on the roof of the bracket. That is the very beginning of our quotient. Then, without missing a beat, we jump into step 2, multiply. We take that 2 on top, multiply it by our divisor 3, and write the result, 6, directly underneath the 8. Next up is step 3, subtract. Just draw a line under there and subtract that 6 from the 8, which leaves us with 2. Now we hit step 4, bring down or finish. We look inside the house. Is there another digit sitting next to the 8 to bring down? Nope, so we're totally finished. That leftover 2 at the bottom, that's our remainder. We just successfully calculated that 8 divided by 3 is 2 with a remainder of 2. Let's kick things up a notch with section 4, dividing larger numbers. You've officially learned the entire mechanism, so now I want to prove to you that this exact same loop works on absolutely any size problem. We're setting up something a bit beefier here, 92 divided by 4. Now, seeing a 2-digit number inside the house might look slightly intimidating at first glance, but please do not panic. The rules absolutely do not change. We are just going to tackle it one single digit at a time. So we pretend that 2 isn't even there for a second and just focus all our attention on the 9. Let's run the loop. Divide, 4 goes into 9 2 times. Multiply, 2 times 4 is 8. Subtract, 9 minus 8 is 1. Boom, We just effortlessly knocked out the first 3 steps on our very first digit.
Now let's see how this builds when we hit step 4. Remember step 4? Bring down. We've got that 2 just waiting patiently up there in the dividend. So we draw an arrow and drag that 2 all the way down to join our leftover 1. And just like magic, our leftover 1 has transformed into a 12.
And now, we simply restart the entire loop from the top, applying it to our brand new number, 12. Divide. How many times does 4 go into 12? Exactly 3 times. We write that 3 up top on the roof, right next to the 2. Multiply. 3 times 4 is 12. Write that down under the 12. Subtract. 12 minus 12 is 0.
And look at that beautiful 0 sitting at the bottom. We do a quick check for any more digits to bring down. There are absolutely none. So we get to celebrate a perfectly clean division with 0 remainder. Just by repeating our simple loop a second time, we easily conquered a much larger number to get a flawless final quotient of 23.
Finally, we reach section 5, the decimal point trick.
This is sort of the final frontier of long division. What do you do when the number outside the house is actually bigger than the number inside? Imagine trying to divide 4 by 5. If you only have 4 items, you obviously can't make a group of 5 out of them, so initially 5 cannot go into 4. This used to be a dead end, but here is an incredibly elegant workaround. We just add a decimal point. By changing that 4 to a 4.0, we haven't changed the actual value at all. 4 is exactly the same as 4.0, right? But mathematically speaking, we just gave our loop the fuel it desperately needs to keep running.
Here is exactly how this trick plays out. How many times does 5 go into 4? 0 times. So we write a 0 up top in the quotient. Then we place a decimal point immediately after the 4 inside the house, and this is absolutely critical, we place another decimal directly above it in the quotient, right after that 0. They have to line up perfectly.
Once that decimal is safely anchored on top, the rules of the house go completely back to normal. We add a 0 inside the house to turn our 4 into a 4.0. Then, we just run step 4 of our standard loop, bring down. We drop that newly created 0 down, which miraculously transforms our impossibly small 4 into a super manageable 40.
To finish the whole thing off, we just run the loop on 40. Divide, 5 goes into 40 exactly 8 times. We pop that 8 up in the quotient right after our decimal point. Multiply, 8 times 5 is 40. Subtract, 40 minus 40 leaves us with exactly 0. There's nothing left to bring down, our remainder is a perfect 0, and we've revealed our incredibly clean final answer, 0.8.
So we've tackled the setup, we've handled remainders, we've conquered larger numbers, and we even outsmarted decimals. But think about this. What happens when you eventually encounter those massive, crazy 5 or 6-digit numbers out in the real world? Well, because this brilliant little 4-step loop, divide, multiply, subtract, button down, literally never breaks, you now hold the key to decoding every single one of them. You have the ultimate no-calculator tool at your disposal. So, what massive number are you going to conquer first? Thanks so much for joining me on this explainer, and I'll see you next time.